So I just saw this on Reddit, and I think it's a very good one. So let's take a look. It says, teacher teaching infinite series for the first time. So, does a series as n goes from 1 to infinity of -1 to the n over n converge? Student, oh yeah, absolutely. Teacher, well yes, but actually no. What exactly is happening? Well, the answer to this question, does this series converge, is yes, it does converge. But we cannot say the series converges absolutely. So we will have to indicate that not absolutely. Of course, the word absolutely when we're talking about infinite series does mean a different thing than the usual absolutely. So firstly, let's take a look why this right here does converge. This is actually the alternating series. We have the factor -1 to the n. Let me write this down like the series as n goes from 1 to infinity, and then put the -1 to the n right here times 1 over n. When we plug in 1 into all the n's, the first term will give you -1 over 1, so that's -1. When we plug in 2 into all the n's, -1 to the second is positive, and then we have 1/2. And then when we plug in 3, we will get -1/3. When we plug in 4, we get plus 1 over 4, and so on, so on, so on. As long as the signs alternate, negative, positive, negative, positive, this right here is also alternating series. How do we check it though? Well, for an alternating series to converge, we can do the following. In this form, as long as we have -1 to the n, sometimes you might have -1 to the n minus 1. That's fine too. And then multiply by an expression bn. First, we have to make sure that the bn is greater than or equal to 0. Then this alternating series will converge if we have these two conditions. First one, the limit as n goes to infinity of bn gives you 0. Secondly, we have to make sure that bn plus 1 is less than or equal to bn. And this means the next term is less than or equal to the current term. And technically, I should say, for our starting n value, n greater than or equal to 1. So this right here, we can just go ahead and check these two conditions. Take this right here to be our bn. Condition 1, do we get the limit as n goes to infinity of bn equal to 0? Yes, because we just have the limit as n goes to infinity of 1 over n. It's like 1 over infinity, you get 0. Next, do we have bn plus 1 to be less than or equal to bn? Let me put down a little question mark first. Well, I will just put n plus 1 into the n right here. We're looking at 1 over n plus 1. Is this less than or equal to bn, which is 1 over n? And right here, I will say that we care about for n is greater than or equal to 1. With this condition, of course, this and that are both positive. Well, the bottom is bigger right here, so you can say this is going to be less than that, which is true. But if you want to be super clear, you can also cross multiply. And since this and that are positive, you don't have to flip the inequality. You get n is less than or equal to n plus 1, which is definitely true. So both of them are true. That means our series right here does converge by the alternating series test. By the way, this right here converges to a very nice value. I will tell you that this right here is actually equal to negative ln2, but maybe we can talk about that later. Now, why is this like not absolutely convergent though? Let's take a look. So for a series to converge absolutely, we will have to apply an absolute value around the expression here. So to check for absolute convergence, we are looking at the series with the absolute value -1 to the n times 1 over n. But the absolute value will make this right here disappear. Every single term out to be positive, so we have the series as n goes from 1 to infinity of just 1 over n. And if you expand it, you are going to get 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 and so on, so on, so on. And in fact, this is the famous harmonic series, and this right here diverges. Because if you add them up, it will go to positive infinity. So, as you can see, the original version, because we have a lot of the negative terms, right? So, all the negative terms prevent the total sum to become a positive infinity. So, that's the idea. But when you don't have the negative terms, when everything is positive in this situation, I know all these numbers, it gets smaller and smaller and smaller, but this right here, slowly but surely, they add up to infinity. I do have another video explaining why this is going to be infinity in detail, so make sure you guys go check that out. The link will be in the description. So, this is why the series converges, but the series does not converge absolutely. So, do we have an example of a series that also converges absolutely? Yes, let me show you. All I need to do is change the n to the second power. This series, does it converge? Yes, and I can say absolutely. So first, let's do what we did earlier. Why does this series converge without the absolute value? This right here is a series as n goes from 1 to infinity. Put a negative 1 to the n like this, multiplied by 1 over n squared. And then we'll take this right here to be our Bn. And we'll check two things. Firstly though, the limit as n goes to infinity of Bn. This right here is just a limit as n goes to infinity of 1 over n squared. This right here is 1 over infinity squared, which we do get 0. Secondly, we check if Bn plus 1 is less than or equal to Bn. And technically I should say for n is greater than or equal to 1. Well, put this right here in there. So 1 over n plus 1 squared. Is this less than or equal to 1 over n squared? You can do what we did earlier, cross multiply. This and that positive, so we are looking at n squared being less than or equal to n plus 1 squared. The reason I did that is because when we have just this without the fraction, it's much easier to tell that this right here is certainly true. Therefore, this series does converge, and we can say by the alternating series test. Now, why does this converge absolutely? So we will have to check the series as n goes from 1 to infinity, apply an absolute value around this expression, and the absolute value will just get rid of this. So we are looking at the series, and then here we have 1 over n squared. And in fact, this is just a p series. The p right here is equal to 2. And make sure you also write the p is greater than 1. Because when we have a p series, the p is greater than 1 will tell you this right here converges. So just say it's a convergent p series. And then we're done. And in fact, this is a very famous question because the sum right here is actually pi squared over 6. But we'll talk about that in another video. So as you can see, the series itself does converge by the alternating series. And if you apply an absolute value to it, the result still converges. So we can say the series converges absolutely. So we can say yes, absolutely for that, but not for the previous one. That's it.